In this video, in the continuing series for information technology audit and cybersecurity, we're going to talk about use cases. This is for systems analysis and design, or the systems and infrastructure lifecycle management. So we're going to continue the discussion on analysis, right? So we've been talking about this analysis phase, and if you recall in the previous video, one of our previous videos, not the video before this one, but before that one, we talked about requirements analysis. Requirements analysis fed into our process analysis, right? So we talked about how to diagram processes. I talked about data flow diagramming, which is a structured technique for diagramming. We looked at the Gain and Sarson method, which you see up here in the upper left-hand corner. And starting in this video, we're going to start talking about using a UML technique to do the same thing. So this is a context level diagram that you see here that we talked about. The context level diagram simply shows our system, and it gives you context as to what the system is going to do by showing you the sources and sinks or the interfaces that surround that system, so anything that's external to that system, and then the various ways that those different interfaces are going to use the system. So if we have something like this, if you've already brainstormed something like this, then you can very easily draw a use case diagram from this. And I'll show you what that looks like. So what we do is with a use case diagram, we start with our system and we draw that as a box, a big rectangle. And that's we call that the automation boundary. And I'll show you these parts later on once we get through this. But we draw the automation boundary first. Everything inside that box is inside the system that we're designing or that we're analyzing. Everything outside that box is stuff that is external to our system. So the next step is we draw our external systems or our external users, anything that's external to the system, and we draw that as stick figures. And I know it looks silly, but this is the official format in the UML standard. If you go read the UML standard, I have a book sitting on my desk right now that describes the UML standard, and this is the syntax, a little stick figure with basically the role underneath it. And you can see here that that I put in the same roles that you see in the context level diagram. So again, this is the stuff external. Now, these don't always have to be people. Sometimes there are other systems. We call them blockheads sometimes because you draw, instead of a circle for the head, you can draw a block, which would indicate that it's another system. Or if it's an API, you might draw a little cog wheel or something like that. There's lots of different ways you could do that, and UML gives you some ideas on how to draw that. So now that we know we have our system, we've got things that are going to interact with our system, then we draw what we call the use cases. So in your context level diagram, those arrows that we're pointing into the system and showing you what's coming in and what's going out, we convert those data flows, right? So we called those our data flows in our context level diagram. We have to convert those into use cases. And the use cases are a verb noun phrase that describes what we're going to be doing with the system, or what a particular user or an interface or somebody external to our system expects to be able to do with the system. And then finally, once you do that, you just connect them to their use cases so we know who's going to be doing what with the system. Now, in my example here, I have, each one of these only has one user connected to it, but you can have multiple. For example, the manager might also be able to get a food order or something like that, right? So you can have some variation there. But this is essentially what we're going to learn about in this unit. So our objectives are to understand the process used to identify a business process and use cases. So what we want to do is I'm going to walk you through the brainstorming technique to discover, basically to discover what the use cases are. I'm going to talk about different ways that we can do that. How we analyze these processes that we learned about in the requirements gathering phase in order to understand the system that we're trying to develop. We're going to understand the process used to create the use case diagram. And then we're going to talk about how to model business activities with an activity diagram. So we're going to switch gears, and then this will be a second video. So this slide deck's going to be split into two parts. So I'll show you activity diagrams. And I'm also going to talk about what's called a fully developed use case description. So we can take that use case model, and sometimes we have to expand on that with a fully developed use case description, which is going to show much more detail. It's not necessarily a model. It's actually a more of a narrative description, but that can also include an activity diagram. So a lot of times we use an activity diagram in conjunction with the use case in our fully developed use case diagram. So the use case gives you that sort of overall view of the system, and then the fully developed use case gives you more insight into a specific use case within the system, and you can use an activity diagram to describe that in more detail. So again, they go hand in hand. So we'll talk about all this stuff in this unit. So first, we're going to begin the process in use case diagram, and we're going to begin the process of turning in our requirements or rather turning our requirements into our functional models. So what exactly is a functional model? The functional model is a model that shows us the functions that our system has to do, right? The things that our system has to be able to do in order to work. That's our functional model. So that's why we call use case diagramming a functional model. So their models are logical. In other words, they're independent of how they're implemented. Whether manual or computerized, it doesn't matter, right? So you can use this to model manual processes as well as computerized process. It works for just about anything. We can develop use cases from our requirements. So a use case is how a business system interacts with its environment, and it can include a diagram and a description to depict the discrete activities that the user performs. So we can develop activity diagrams from our use cases, which I'm going to show you how to do. So first, the elements of a use case diagram. Use case diagrams typically will include actors. These are the users or anything else that's interacting with the system. It doesn't necessarily have to be people. Actors can also be other systems, for example. And the symbol, again, is a, I just took this from the UML standard, but that's the symbol for an actor. Associations are lines to connect actors to use cases. As you can see here, just a simple line. That's called an association. And then a use case is the actual process. That's the actual use case, right? So that's what we're going to be doing with the system. You just draw that in an oval. And then the subject boundary, some textbooks call it a subject boundary. I've usually seen it called an automation boundary, but you can call it either one, either the subject or the automation boundary. And that's it. It's a very simple, this is probably one of the easiest drawings to create for UML, for the Unified Modeling Language. They're going to get a little bit difficult from here, a little bit more difficult, but not terribly difficult. But it is critically important to get a use case correct, because a use case is going to drive the rest of our development in our systems analysis and design. It's going to drive the rest of the process. If you haven't accurately captured the functional requirements, which is what we show on a use case diagram, it's going to ripple through the entire project. It's going to ripple through the entire system that we're designing. So it's really important to get the use cases correct from the beginning. All right. So first, identifying major use cases. So we're going to review the requirements definition, identify the subject's boundaries, identify the primary actors and their goals, identify the business processes, and then we're going to review all that to make our use case. But let's get into a little bit more detail here. How do we identify use cases? Well, basically a use case is an activity that the system is going to perform, and it's usually in response to a request by a user. So you can think of, how is my user going to interact with my system? What is the user going to do with the system? What are they going to ask the system to do? And these are usually functional requirements. So, generally things our system does in response to a user or another system is a functional requirement. I'll talk more about functional versus non-functional requirements in another slide deck. So the analyst is going to decompose the system into a set of use cases that's called functional decomposition, which we talk about in this unit. And there are two techniques for identifying use cases or functional decomposition. One is the user goal technique, and the other one is the event decomposition technique. So functional decomposition, which is identifying the use cases, there's two ways you can do it. It's user goal technique and event decomposition technique. Every use case should have a verb-noun phrasing. In other words, doing something, right? So a verb-noun phrase. So first I'll talk about the user goal technique. This is the easier of the two. Easier in the sense that it's not terribly complicated, but it's also not very thorough. Step one is we identify all the possible users for the new system. Then we're going to classify all the users into functional roles. For example, shipping might be a role, marketing, sales. Right? Think about all the departments in the company that you're analyzing or organization that you're looking at, for example. Step three is we're going to classify users into organizational level. For example, operations, executive, professional, right? So, what level are they at? Then we interview to find a list of specific goals. And again, hopefully we've already done this in the requirements gathering phase, but and a lot of this does work hand in hand with the requirements gathering phase. But we're going to look to try to capture any verb-noun phrasing that people are using as they're describing what they do and how their workflows work. We're looking for that verb-noun phrasing to help us identify what it is they're expecting to do or that they do with a system. And then step number 5 is we're going to create the case list organized by user type. We're going to look for any duplicates and resolve any inconsistencies, identify where different types of users need the same use cases, and we're going to review all that with the users and the stakeholders, and then we should be able to get our use case diagram. We now have everything that we need to create that use case diagram because we've identified who the external entities are, what the use cases or functional requirements are going to be, how they connect to those use cases, and we know what's inside the automation boundary and what's outside the automation boundary. So pretty straightforward. So the event decomposition technique is a little more comprehensive and a little bit more complete. It's going to identify events that occur to which the system must respond, and for each event, we're going to name a use case with a verb noun phrase that describes what the system must do when that event occurs. So an event is something that occurs at a specific time and place, can be described and should be remembered by the system, which is the important part. So that's roughly what an event is. So the event decomposition technique, we might look at something like this. We'll say a customer pays their bill, or a customer makes a charge, or a customer changes their address. Those are all events that we might identify. But where the event decomposition technique takes a step further is that it can also identify temporal events, such as when it's time to send late notices, or it's time to send statements, or time to produce end-of-week reports. These are things that happen that are not instantiated by those users that you see around the system. So the event decomposition captures what we call temporal events. If I were going to name these different events that I've identified in my requirements gathering phase, I might call it record payment, process charge, update customer, send late notice, produce statement, produce reports, and you can see the verb noun phrasing here, which is typically what we're looking for in a use case diagram for a use case. So some types of events. An external event is any event that occurs outside the system. So it's initiated by some external agent or actor, right? Those little stick figures that we talked about. A temporal event is some event that occurs as a result of reaching a point in time. And again, this is something we usually don't think about in the brainstorming technique, which is not very structured. But here, we start with what are the external events, then we think about what are the temporal events, and then finally what are state events. And a state event is when something happens because the state of something changed, right? So something occurs when something happens inside the system that triggers some other process. For example, if our inventory dips below a certain level, that might trigger the reorder of stuff for that inventory item, right? That doesn't happen at a certain time. It happens when a certain state is reached. And we're going to talk later on, this is going to go hand in hand with another type of UML diagram that we'll learn about called a state machine. So we're going to talk about a state machine later on, and we use those as well. That's going to be in structural modeling, where we talk about that, and a little bit in behavioral modeling. So an external event checklist. For example, an external agent or actor wants something resulting in a transaction. External agent wants some information, or an external data changed and needs to be updated. Management wants information. These are all things we can look for external events. For temporal events, we want to look for internal outputs that are needed at certain points in time, or external outputs that are needed at certain points in time, right? So anything that's timing oriented or happens at a certain point in time. So as far as finding the event, in this requirements gathering phase, you might have interviewed somebody and you said, let's say it's a retail outfit, right? It's a retail organization, and you've interviewed them, and you say, okay, explain to me the process of a customer buying a product. And they're going to tell you, well, okay, so the customer first is going to think about buying a new shirt. Then they're going to get in their car and they're going to drive to the mall. They go to Sears. They try on the shirt at Sears, but then they decide to come over to our store at Sprawl Mart. They try on the shirt at our store, and then they purchase the shirt. They buy the shirt. So to them, this is the process to buy a shirt. But to us as analysts, what in this whole process is salient for what we're doing? Well, the answer is we only care about the last part, the customer buying a shirt. And that's what we're looking for when we're looking for use cases. We're looking to strip away all the things that don't happen inside the system, right? When I talked about the hamburger stand in our previous unit, I talked about how there's no there's no hamburger in the use case diagram, or in the data flow diagram. We don't see a hamburger going to different places because the hamburger is not inside the system. The hamburger's on the grill. It's going to somebody who's handing it to a customer, but that never really goes into the system, so we don't care about that. Here, I don't care that the customer's thinking about buying a shirt. That's important to their organization, and it's certainly important for them to think about that and to understand the ramifications of the fact that customers are going to other stores first and so forth. But that's outside of the scope of what we need to be concerned with. There's no reason for us to get involved in that. So we only care about buying a shirt. So this is one of the challenges in identifying functional requirements, is we have to strip away all of the things that really aren't important for what we're doing. They're not relevant to our system. As far as temporal events, and really any other types of events, another way to look at events is looking at a sequence of transactions to try to identify events. Like a customer might request a catalog, then they check if an item is available, then they place their order, then they change or cancel their order, they check their order status, they update their account, or they might return the item. And this would be looking at end-to-end workflow, right? So this is workflow analysis. We say, what is the sequence of events that could happen if somebody did everything with the system, if a certain actor, for example, did everything that they could with the system? Now, one thing about doing this analysis about functional requirements is you want to try not to find too many use cases. And that's why sometimes it's important, especially in the analysis phase, to use what we call the perfect technology assumption, which means let's not worry about the things that are already well understood in almost any system. For example, logging in, changing your password, setting your preferences, doing backups, security, and non-functional requirements like, requiring certain passwords and things like that. All of those things we can figure out in the design. Anything that is commonly found in just about any system, we can ignore. We don't have to worry about that stuff. That minutia is going to get figured out later on. So try not to get bogged down in technology. Let's think more about workflow. That's the important thing for us to understand is the workflow. So these are the steps for the event decomposition. You're going to look at the external events, identify and name the use cases, then look at temporal events, identify and name those use cases. Then you're going to think about state events or identify your state events, again from your requirements gathering. Then you're going to identify and name those use cases. Now that you have all of your use cases, you're going to compile all of those, figure out which actors are going to interface with those use cases, and then plop them on that diagram that we talked about before. Now, which is better, user goal or event decomposition? Technically, events are broader than the user goal because it captures both temporal and state events. So the event decomposition is a little bit better than user goal because if I asked you want to test which is better, which one captures temporal and state, the answer is event decomposition, not brainstorming. The reality is it's kind of hard to draw any differences between these two because it feels like we're brainstorming in both, but what I'm really not able to show you in a PowerPoint here that you'll see in the field is that event decomposition is where you're relying on your requirements gathering in order to determine the use cases. Where with the brainstorming, you're more thinking about how a system might work in order to do those requirements. So it's relying on your experience and your understanding of what a system should do, as opposed to relying on what the users told you the system is going to do. So event decomposition is definitely more structured. It's more using what you've learned in the requirements gathering phase, but it does require that you use a lot of those techniques in the requirements gathering phase and that you're very thorough in the requirements gathering phase. Now, there is one other way that we can identify use cases, and sometimes this technique crosses the line a little bit into the perfect technology side. And a lot of times we use this technique more so in the design phase. So when you're actually using use case diagramming to do your design for a system, a lot of times we use the CRUD technique. CRUD stands for create, read, update, delete, right? And if you've taken a database class, or if you know much about databases, you've probably heard those terms before, right? Like select, insert, update, and delete, same idea. So we think about those 4 basic operations that we would have to do with any data: create, read, update, and delete. And we try to make sure that we cover all of those different things that we could do. I haven't used the term domain class yet. When I talk about domain classes, we're talking about things that our system needs to keep track of. We're going to talk more about how to come up with domain classes later on. But for right now, just understand that a domain class is anything we've identified that must be remembered by our system, right? Some people might call that persistence, anything that has to be persistent within our system. So stored between runtimes if you're a programmer or something like that. So for example, if I have a class called customer, right, a thing in my system I have to keep track of called a customer, then probably I'm going to have to be able to create that customer. I have to be able to read that customer, or report on that customer. I have to update that customer, and I have to delete that customer. So then I would come up with use cases that describe each one of those operations that I would need to do. Now again, this kind of crosses over into that perfect technology assumption area because we know we're going to have to do all this stuff anyway, and almost every system can support these things. So this might fall more in the design area, not so much in the analysis. And right now, I want you to try to, for the purposes of this course and learning about this process, in the analysis phase, we're trying more to think about what the system needs to be able to do as a whole and less about the minutia of these small tasks that fall into technology. So that's certainly something to keep in mind. So you don't necessarily have to do this CRUD technique when we're doing our analysis phase use case diagrams. We might be doing this more in our design phase later on, adding this stuff because we know we have to be able to update, delete, and and so forth. A lot of this stuff is kind of a given once you get into the design. Now, once you have your use cases defined, the next step is you have to describe those use cases. So you're going to want to try to give us a brief narrative on exactly what that use case is. So we have a very simple name for a use case, like create customer account is a use case. And then you'll have a simple description that kind of describes, like user enters new customer account data, the system assigns account number, creates a customer record, and then creates an account record. That's a use case description. So it's important that we have some understanding of what that use case is for. It's not always obvious exactly what a use case is going to do from that very basic verb, noun, phrase. So you have to expand on that a little bit with a use case description. And these are 3 examples for you of use case description. So you're going to want to make sure that you decompose your use cases on your use case diagram with an initial description to describe those. It does not have to be on the use case diagram. It's typically referenced in a separate document. So you would not put this directly on the use case diagram. You want to try to keep the use case diagram itself as simple as possible. And I'll show you some more examples of use case diagrams here in just a little bit. So a use case diagram is that UML model that I showed you in the very beginning. If you recall, UML is the Unified Modeling Language. It's the standard that we use for software development and design, and it's also a standard for systems analysis and for defining requirements on systems and so forth. We talked about the actor, which is the UML name for an end user, right? So that's what UML calls an actor. So let's talk about the syntax for a use case diagram. I'll try to show you what the standard is here. So as I talked about before, the stick figure is called an actor. And that's the thing that's interacting with our system. So that was an interface in our data flow diagram using Gain and Sarson. Then we had our connecting line, which shows the actors or how the actors participate with use cases. In other words, which use case an actor uses. That line should show us that. Then you have your actual use case, which shows you what the system is going to do for that user. And then the automation boundary, which shows you the system, what's inside the system and what's outside the system. And I will tell you that in industry, a lot of people leave off the automation boundary. It does seem a little superfluous because it's just a box around those use cases. There's really no other way to, that you'd be able to draw it anyway. So some people do leave the automation boundary off, but the official standard is to include the automation boundary to make it obvious as to where, what's inside and what's not inside our system. So as far as the steps for doing a use case diagram, you're going to identify all of your stakeholders and users who benefit from seeing a use case diagram. Then you're going to determine which stakeholder or user needs that you have to show on the use case diagram. You're going to select the use cases and actors to show and draw the use case diagram, and then you're going to name each use case diagram. So the long and short of it here is that you're going to have not just one use case diagram, but you'll probably have many use case diagrams. So not just one, you'll have a whole bunch of use case diagrams. So these are the different types of use cases. And this just shows you the purpose and the amount of information in each of these different types, just a little matrix here. You can certainly pause the video and take a look at that if you like. So the elements of it, so once we have our use case diagram, we talked about that use case description, but in many cases, we have to make what we call a fully developed use case description, which means that we expand upon that use case even further and give even more detail. We do this when we have a particularly complex use case. So when we have a use case that's really complex, we have to decompose it to make it more clear as to what that use case is doing. So that more complex description, that fully developed use case description, which you'll see in the UML standard, has these parts. You're going to talk about, you're going to give an overview, which will include the name of the use case. You might have ID numbers for each one so you can keep track of them if you have a very large, complicated system. Who the primary actor is for that use case, a brief description, how important it is, who the stakeholders are, the triggers in case it's either a state or a temporal use case. You'll talk about the relationships of that use case between actors and other use cases and things like that, and even classes, which we'll talk about later on. The flow of events for that use case. So there's going to be, a lot of times there's a dialogue between the use case and the interface outside the system. And that could be an API outside the system. It could be an actor or a user outside the system. But think about how you use computers. There are things that you use the computer for where to complete a task, you're going through menus and dialogues and answering questions and going back and forth with the computer, and sometimes that needs to be fully defined. And we're going to do that in a use case diagram. And one of the ways we'll do that is with an activity diagram, which will show how we carry out that use case, which I'll show you in a little bit. So some writing guidelines, you're going to write in the form of subject, verb, direct, object. Make sure it's clear who the initiator of the step is. Write from an independent observer's perspective, right? Not from the perspective of the actor. You're going to write about the same level of abstraction. So you're not going to change your level of abstraction as you describe things. Ensure the use case has a sensible set of steps. Apply the KISS principle, which means keep it simple, right? I'll leave off the last S. And write repeating instructions after the set of steps to be repeated, and so forth. So you're going to pick a high priority use case. So what do we need to decompose with a fully developed description? The answer is you're going to start with a high priority use case. You're going to list the primary actor, determine its type, list all the stakeholders, determine the level of importance of the use case, briefly describe it, list what the triggers are, list the relationships. Then you're going to fill in the steps in the normal flow of events that are required to complete the use case. Ensure that the steps are listed and not too complicated. In other words, they're understandable, right? Then we're going to identify and write the alternate or exceptional workflows. In other words, what do we do if something goes wrong? What do we do if something doesn't fit into the model, right? We have to explain what's going to happen when somebody gives us the wrong answer, right? So how do we handle those exceptions? We're going to carefully review that description and confirm that it is correct. And then we're going to iterate all of those steps again and create additional use cases or fully developed use case descriptions. And this is just an example. This is from one of our textbooks that shows you what a fully developed use case description might actually look like. So you can certainly pause this and take a look at it if you want to get a better idea for your assignment. I think I do ask you to try to give me at least one fully developed use case description for the practical assignment. So as far as verifying, use cases have to be verified and validated before you begin structural and behavioral modeling. So use case diagrams, as I said before, are the basis for everything else that we're going to do in our analysis and our design. They validate our understanding of what the system, the basic understanding of what a system at a very high level needs to do. If we don't get that right, it's going to ripple through the everything else we do. So we have to make sure we get this right. So we could use a walkthrough where we perform a review of the models and diagrams that we've created so far. It's performed usually by the development team and the client. It's very interactive. We're going back and forth. We'll probably include a facilitator and a presenter and a recorder to record anything that we're learning as we go through this. So as an example, here's a simple use case. We have a customer service, a store rep, and a manager. And let's say we're designing a system for a customer loyalty system, right? Like frequent flyer system, or like when you go to the grocery store and you get points for buying stuff and then you get a free ham at Christmas time or something like that. That type of system. If we were designing a system like that, our customer might want to be able to manage their account, as well as customer service and a store rep. A customer might want to be able to connect to a friend, right? So let's pretend in this little system, we're going to make it so that you can give your points to other people. You can gift them to somebody else. You can say, okay, I earned my free ham, but I'm going to give it to somebody else so that they can get my free ham. So you can connect to a friend. You can accept a friend if they try to connect to you. You can view your points to see how many points you have, which a lot of people would want to know. You can write messages or read messages from someone about your points. The manager could adjust points. Maybe something got messed up, or maybe they want to give a customer some extra points because they told them about a spill in aisle 5 or something. I don't know. You can send the points to somebody and you'd be able to receive points. So this is how we might draw a simple use case that describes how the customer and the customer service and the store reps are going to interact with this customer loyalty system. And again, this might be just one part of a much larger system, right? This is just the customer loyalty component of a much larger system. So we would have other use case diagrams describing other things in our system. Here's another example. Let's say we have a customer that wants to be able to search, view a product, look at accessories, fill their cart, empty their cart, check out, empty their cart again. I don't know why I have that twice. That would be redundant. We wouldn't normally do that. So that's another example. This is just one actor and different ways that they're going to interact with the system. But it's certainly a valid way to draw a use case diagram. And then there's some more advanced things that I haven't talked about in this presentation. I want to save it for later on. We might come back to this later on, but sometimes use cases can include other use cases. right? And this is the syntax you would use to do that. And you'll see this in the UML standard, but I don't want you to worry about this yet. In the analysis phase, let's worry more about keeping it simple and making sure that we can use what we've learned so far to express our understanding of the design for a system, or what those functional requirements are for a system. This is another example from another college textbook I have. This is a library book collection management system. This is from a Wiley textbook I have laying around. So again, it's another pretty good example, right? Here we have a librarian and a borrower. I would say if I drew this, I'd probably include the circulation desk, but it just shows the different things that people would do at a library. For example, the librarian's going to process overdue books. They're going to maintain their book collection. The borrower is going to be able to borrow books, search the collection, return books, right? All the basic stuff that you and I would expect to be able to do with a library, right? Okay, so in the next slide deck, I'm gonna pause this and I'm gonna create a second video in this slide deck about activity diagrams.